So right now I am in my IntelliJ in presentation mode. Let's start solving this problem here. And I will take the same method name as given here in lead code. It's better to mark it as private static and final, make it immutable. Okay, so let's start solving this problem. I'm in the algorithm that we have created here, starting with 2 pointers. Okay, so let's start with the base case first, right? When we have given the number of rows as 1, we simply return this 1. As given here as well, that number of rows is equal to 1. So we have to simply return this. And in the constraints also, we can see that the number of rows can be 1 till 30. But before that, let me create the final result that I'm going to return, because this generate method returns a list or list of integer, which represents the Pascal's triangle. So simply I will copy this. And this is our result. Let's mark it as array list. And then our base case, I will add it immediately here. Okay. So we are creating a result which we are going to return in this for this generate method. And in the very first list, I have created this list of 1, which I have added to the result. Okay, so there's a list inside the result. Because each of the elements, each of the rows, for example, it would be a list in itself. So for each row represents 1 list, and we have to return the list of integers. So that's why I created for the base case a list inside a list of result. Okay. Now let's check for the base case again. If number of rows equal to 1, then we simply return the result, right? We don't need to go and do any other logic for 1 for the base case. Now as we have created this formula here, that we start with I and j, and we append 0, 0 for the previous one, and then we calculate this using this formula. Let's implement the same here. So I will start with a for loop. I will start with 1 because for 0, that is number of rows is 1. We have already calculated it here, our base case. So I start with 1. And we move towards number of rows here. And now, first of all, we have to append 0. I mean, append and prefix. I mean, suffix and prefix both as 0 with the previous DP that we have calculated. So let's do that by creating a temp list. This temp is because I need to mutate the original DP. That's why instead of that, I'm creating so I'll just do result.get I-1. Right? So it means that I have got a list of 1 first. So this temp right now is this, that I have just took this from the previous DP1. So my temp list is only containing this element 1 here, because result.0 is this list. Okay, so now I need to first of all append a 0 here. 0. This part, right? We are appending a 0 here, this one. So we temp.add, because add, it automatically appends at the last of the list. So this is append 0. And similarly, I need to prefix, I mean, here we need to put it here at the first element, right? So for that, we have the function method in Java for the list as at the 0th index. You can see this is int index or integer element. So at the 0th index, I need to append 0. So it would be, we can say that prefix with 0. Okay, so these are the two things that we have done. So we took the original list, which from the result, the previous DP array. I mean, you can say that, for example, for DP3 it would be DP2. DP2 is presenting the temp here, and then we append a 0. I mean, we put 0 here and then also 0 at the beginning. This is what these two statements do. Now we have got this temp list from the previous one, and now we finally create the DP of the current row that we are going to calculate using the temp or the previous row we have created by appending zeros. So this is my, again, I will create an array list. Okay, and now we have to simply loop through. Okay, yeah, so I is already there. We don't need to create another one. We just simply need to loop through this temp and just add the elements which are there, right? Like, for example, for this first element, for the DP3, we have to add temp of 0 with temp of 1. Similarly, this would be, then we shift J to the next element, and then it will be temp of this plus this. So just let's implement this. Okay, so we start with J equal to 0, and we go to till the result.get I minus 1 dot size, right? Now we append this. So we have to just simply add temp.get J plus temp of the next J plus 1, right? That's it. By exhausting all this row, we are doing this exactly same formula as we done here. So instead of maintaining I and J2 variables, what I have done is that I've just chosen one J starting with 0, and just using J and J plus 1 to do the same thing, and calculate each element by from the temp from the previous DP array that we created, and that's how we got for each element. And once we are exhausted with all the elements, including the 0, then we are done, and we have our final row created here. For example, this row will be representing, say, DP3 if the temp was DP2, and then simply we need to add or append again the result, which is row, right? That's it, guys. This is the whole algorithm. We just do the iterative approach. We just go through each and every element in the previous DP array, represented by temp, and then we calculate the current row Pascal triangle, and then add it to the result. And then once we are done with all this, we simply return the result. Okay, so let me remove some extra lines here. Okay, now let's run this for the example which was given. So generate number of rows 5. So I will just create Pascal's triangle, right? Make with the name, mark it as final. Okay, now I want to actually do a pretty, in the row format. So for that, I will just use the for each loop. Use for each, and for each of the row. So this row would be each of these integers that we have calculated, and I will try to print it into a better formatted way. Okay, so now for each row, I would with the number, for each number is there, I will use as printf. Printf is better. Just use this like this, and pass this num here. Okay, and once this is printed, I will simply do a system.out filter. Okay, now let's run this. Okay, so this gives me the Pascal triangle exactly same as we calculated. So let's finally copy this solution, sorry, and print it into, give some space here, and let's run this. So our sample test cases works. Let me submit it now. Okay, so it works well. Now let's quickly do the time and space complexity. The time complexity would be, because we are using two for loops here, right? So it would be roughly O of n square. And also for the space complexity, right? Because we are storing the result. I mean, because this is the expected result, right? So we are just just creating one temp array in between. But again, I mean, this is the expected solution. So it can be like, arguably, we can say that it is O of n or O of 1. Okay, because we are not, because the solution actually expects a list of integer, and we are just creating one extra list here in between. But eventually we are adding this in the result. So this is the only temp that we are creating extra. That's why I marked it as ON. So it should be actually ON. So this was the time and space complexity. And we are done with this Pascal's triangle problem. So we have solved 17 problems so far. In the next video, we will solve the 18th problem of our tutorial series on dynamic programming, which is decode base. And we'll solve this problem in LeetCode. So see you all in the next video.